Hi all, welcome to my channel, and this is the fourth video on structural design patterns. I have already shared complete videos on creational design patterns and also 3 videos on structural design patterns. If you missed the video, I'll put the link in description. Please go and watch and come back. So today we are talking about bridge design pattern. This is somewhat trickier design pattern and also very easy design pattern to understand with multiple examples. Before going to talk about bridge design pattern, let's what actually bridge means So think about a bridge as a way to connect two lands. We have two different lands, and there is a sea is there, and there is a bridge is there, which is basically connecting the two lands. Which means how we basically construct the bridge, which should be independent of basically connecting the lands, right? The bridge allows people to cross from one land to other, but the design of bridge and the lands can change independently. That is basically how bridge works. Now let's talk about standard definition of what exactly bridge design pattern. Decoupling an abstraction from its implementation. I am decoupling an abstraction from its implementation so that two can vary independently, which means if I mention red circle, blue square, blue circle, blue shape, which is basically these are all abstractions. I am and this is implementations. I'm basically decoupling abstractions from its implementation so that I can work on independently. So circle can has red, circle can has blue, square can has red and square can has blue. With a minimum set of subclassing, I can achieve the decoupling of abstractions from its implementations. So this is the example which I am going to talk about with the help of coding. If you didn't understand this example, I will talk about later. Let's talk about very another example which anyone can easily understand, because people love cars, right? So the help of car example you can easily understand. Let's say I'm the owner of car manufacturing company. So let's talk about design with examples So I'm the owner of car manufacturing company. So I want to design family cars, and also I want to design luxury cars, and there are some crazy people like me who want sports cars, and also I want to design sports car. So if you think about family car, luxury car, sports car, what are the requirements? What all things are included in to design a car? One is basically engine might be required, and wheels might be required, which are basically not tightly coupled with the particular car. Engines and wheels. These are basically common properties across cars, which means those are my abstractions. I need to take out. Let's say we write what are the things are required. Let's say I required wheels. What else I required? Let's say I required engine. For now, let's say 2 examples, and these two should be common across family car, luxury car, and sports car. So, which means these two are basically my abstractions. So these three are basically I'm manufacturing, so I need to implement these three to my car manufacturing company, and these three are dependent on wheel and engine. If you didn't perform subclassing, just how I explained in the first example, you're indirectly making very tight coupling to the implementations and to its abstractions. So we are basically removing all the abstractions and create separately, and making all the implementations. Let both work separately, and we just use these things whenever it is required. So luxury car contains wheels and luxury car contains engine. Family car contains wheels and family car contains engine. So there is a master called car. Basically car is basically implementing luxury car, family car, and sports car, and car contains wheels and car contains engine. So you can use a luxury car with this. So this wheel cannot be single one, right? So let's say something like lightweight wheel. uh, more speed wheel, something like that. Like, so say I'm very bad at like naming, so please bear with me. Like, so this wheel can be different things, and the engine also. Let's say engine has like HP engine or different kind of engines, and so wheel is basically we basically extract out the abstractions. So wheel is one kind of abstraction. So and also wheel has like a list of implementations are there, like lightweight wheel or more speed wheel. So I am using wheel inside my car. So you can basically link your link. So let's say somewhat looks. So yeah, and so if you see like it has luxury car and it has a family car. So basically car has like different implementations called family car, luxury car, and also sports car. And also we are basically extracted out all the common properties like wheel and engine. Like this way. Similarly for engine also, I'm using the wheel as a composition in the car interface. So I can either use the any kind of wheel I want. Like, so these are like independently working and these are like independently working. Everywhere there is no dependency on there, which means like we successfully decouple the implementations with the abstractions, and we work both are independently. Like changing one might not breaking the other interfaces or abstractions code. That's exactly definition of like car manufacturing company. The company can use the bridge design pattern to separate the engine and wheel components from the actual car design, so that the engine and wheel components are the abstractions and the actual car design, like sports, family or luxury car, is the implementation. This way company can change the engine or wheel components independently without affecting the sports car or family car. So if you have this kind of architecture, you are the marketing in the car manufacturing company. So I have provided like some of the important points to note down. These I have taken from a Gang of book only. Like, you want to avoid the permanent binding between the abstraction and its implementation. Just now we have checked both the abstraction and implementation should be extensible by subclassing. So should be extensible by both the abstraction and implementation should be extensible by subclassing. Changing the implementation of abstractions, it should not impact the client code, which means it shouldn't be recompiled every time. So all three things we have achieved. Now let's see the sample code. Let's talk about like shape. So shape is an abstraction and color is an interface. So in the example, right, what I have just discussed, what I have just shown in the example. So shape contains the color. I am making the bridge as a contains keyword between shape and color. So shape is an abstraction, and shape has like three different shapes: circular shape, rectangular shape, and triangle shape. Here I am bridging the color. I am passing the same color in the constructor. Same for interface. Interface has like so interface is basically implementations, right? Like so interface has like some different colors like black color. So in the driver program, I can use the color to my rectangle. I can use my color to my circle. I can use another color, another property to my circle. I can use the another property of color to my triangle. So these interfaces and abstractions both are like decoupled, and changing the one behavior is not impacting the other behaviors. Like, so this is the way how we should implement the bridge design pattern. So if you run the program, right, it will exactly prints like this: rectangular painted black, circle painted red. So bridge pattern is a one pattern which you may not get in the first go. You need to rewatch the video multiple times, or you can anyway I have shared this particular MD file in the GitHub, right? You can basically go and rewatch my video, or either you can basically go and rewatch my example also, and also all the information which I provided. Bridge pattern is also one of the important pattern in the structural design patterns because it's very hard to understand. Like, so I think that's it for today's tutorial. So in the next tutorial, I will explain the composite design pattern. So there are 3 design patterns which will comes to end of structural design patterns. So please like and say it to your friends, and please subscribe. If I get more subscribers, it makes me to do more videos, and future is planning even more like videos like HLD and LLD also. So yeah, for the next video, please stay tuned and please click on thumbs up. Like, for now, bye bye.